Hi, hello, my dear students. Welcome to Mass Physics-Mnr. This is Nagaraju, Chemistry Senior Faculty. So, students, today topic name is States of Matter 4 and 2 marks. So, this chapter 4 marks, 4 marks వస్తుంది, ఒక 2 marks cover అవుతుంది. So, total 6 marks weightage. So, students, this is first one. Write the postulates of kinetic molecular theory. So, this is very important answer. Postulates of kinetic molecular theory. So, first one, large number of tiny and discrete particles also present. Tiny and discrete particles also known as discrete particles, also known molecules. So, first one, gaseous, one vessel is taken. These are small tiny particle. This is also known as molecules. Gaseous లో ఉన్న చిన్న చిన్న particles ని molecule అంటాం. So gaseous are contain large number of tiny and discrete particle, that is also known as molecules. These gaseous molecules moves to random direction with high velocity, collisions with each other with the walls of the container, then change in the direction of the molecule. So gaseous molecules moves to random direction with high velocity, collisions with each other, with the walls of the container, then change in the direction of the molecule, direction of the molecules. So students, when gaseous molecules moves to forward direction, then it is collide to container also. When it is direction also changes, forward is converted into backward. So gaseous molecules moves to random direction with high velocity, collisions with each other with the walls of the container, then change in the direction of the molecule. Next one, third one, gaseous molecule, it is not affected by, gaseous molecules are not affected by any gravitational force, gravitational forces. So gaseous molecules are neutral. Gaseous molecules are neutral. So there is no attraction. There is no attractions and repulsions between gaseous molecule. So students, gaseous molecules neutral. So there is no attractive force and repulsive force between the gaseous molecule. Gaseous molecule neutral గా ఉండడం వల్ల వాటి మధ్య ఏ విధమైన అట్రాక్షన్స్ ఉండవు అండ్ రిపల్షన్స్ ఉండవు, బికాస్ దీస్ ఆల్ ఆర్ న్యూట్రల్ మాలిక్యూల్. సో gaseous molecules are not affected by any gravitational force. ఇవి ఏ విధమైన గ్రావిటేషనల్ ఫోర్స్ కు లోను కావు. నెక్స్ట్ వన్, యావరేజ్ కైనెటిక్ ఎనర్జీ ఈజ్ gaseous molecule. Gaseous molecules average kinetic energy directly proportional to absolute temperature. So this is perfectly, this gaseous molecule collision is gaseous molecules collision is perfectly elastic. Collision is perfectly elastic collision. So students, first sentence observed, gaseous or contain large number of tiny and discrete particle also known as molecules. This is small tiny particle also known as gaseous molecule. Gaseous molecules moves to random direction with high velocity, collisions with each other with the walls of the container also. When walls of the container attached, then direction also changes. So gaseous molecules moves to random direction with high velocity, collisions with each other with the walls of the container, then change in the direction of the molecule. Next one, third sentence is observed, gaseous molecules are not affected by any gravitational force. Gaseous molecule ఏ విధమైన gravitational force కు లోను కావు. Fourth one, gaseous molecules are neutral. So there is no attractive forces and repulsive forces between the gaseous molecule. Gaseous molecules లో న్యూట్రల్ గా ఉండడం వల్ల వాటి మధ్య ఏ విధమైన అట్రాక్షన్స్ ఉండవు అండ్ రిపల్షన్స్ ఉండవు. Next one, gaseous molecule average kinetic energy is directly proportional to absolute temperature. Kinetic energy అనేది టెంపరేచర్ కు డైరెక్ట్లీ ప్రపోర్షనల్ గా ఉంటది. Next one, gaseous molecule collision is perfectly elastic collision. This is so students, these all sentences are postulates of kinetic molecular theory of gaseous. Second one, it is observed, deduce the Boyle's law, Charles' law, Graham's law, Dalton's law, kinetic energy from kinetic gas equation. Already known kinetic gas equation formula, PV equal to 1 by 3 mn c square. This is kinetic gas equation. So where PV equal to 1 by 3 mn c square, this is kinetic gas equation. Deduce the first one, deduce the Boyle's law from kinetic gas equation. Boyle's law from kinetic gas equation. Kinetic gas equation. So first one, Boyle's law means already known, at constant temperature, volume is inversely proportional to pressure. This is Boyle's law equation. Temperature is constant. Next one, according to Boyle's law, PV equal to 1 by 3 mn c square. This is kinetic gas equation. This equation is multiplied divided with 2. PV equal to 2 by 3 into 1 by 2 mn c square. So already known 1 by 2 mn c square Ke. PV equal to 2 by 3 into Ke. So already known Ke equal to Kt. Ke directly proportional to T, where Ke equal to Kt. Substituted PV equal to 2 by 3 into Kt. So observed, according to Boyle's law, temperature is constant. So it is given temperature is constant. Temperature constant. So observed, this is a 2 by 3 constant, that equal to constant. So then PV equal to K. This is deduce the Boyle's law from kinetic gas equation. So students, repeated, First one, what is Boyle's law? According to Boyle's law, at constant temperature, volume is inversely proportional to pressure. So, from kinetic gas equation formula, PV equal to 1 by 3 mnc square. So, this equation is multiplied divided with 2. Then another equation is obtained, Ke equal to Kt, substituted at constant temperature 2 by 3 constant, then PV equal to K. This is deduce the Boyle's law from kinetic gas equation. So this is known. Charles' law is very simple. Next one, deduce the Charles' law from kinetic gas equation. So kinetic gas equation formula already known. PV equal to 1 by 3 mnc square. What is Charles' law? Charles' law explanation. Pressure is constant. So it is given V is directly proportional to T. P is constant. So according to kinetic gas equation, PV equal to 1 by 3 mnc square. Above equation multiplied and divided with 2. Multiplied and divided with 2. This is also multiplied and divided with 2. Divided with 2. So this is also next. Then formation of PV equal to 2 by 3 into 1 by 2 mnc square. Already known 1 by 2 mnc square Ke. PV equal to 2 by 3 into Ke. Next one already known Ke equal to Kt. Then PV equal to 2 by 3 into Kt. So V equal to taken 2 by 3 into K by P into T. Then pressure is constant. So it is given. This is the equation is taken 2 by it is constant. V equal to Kt or V by T equal to K. This is Charles' law. So students, deduce the Charles' law from kinetic gas equation. This is kinetic gas equation. This is Charles' law. So 2 by 3 into pressure is constant. According to Charles' law, pressure is constant. So V equal to Kt. This is deduce the Charles' law from kinetic gas equation. Next one, deduce the Graham's law also taken, Dalton's law and kinetic energy. Deduce the Graham's law from kinetic gas equation. From kinetic gas equation. So kinetic gas, Graham's law already known. Rate of diffusion is inversely proportional to square root of density. It is constant temperature and pressure. So already known, PV equal to 1 by 3 mnc square. So next one, C square is taken 3 PV by Mn. So it is taken M into N, that already known, M capital M molecular weight. So C equal to under root of 3 PV by M. So already known, V by M equal to 1 by D. Then C equal to under root of 3P by D. Next one, it is taken at constant pressure. At constant pressure, C is inversely proportional to 1 by root D, where C equal to R, rate of diffusion. So R is inversely proportional to 1 by root D. This is Graham's law from kinetic gas equation. So according to kinetic gas equation, PV equal to 1 by 3 mnc square, where C square is taken, then where C equal to root 3P by M, V by M equal to 1 by D, root of 3P by T. At constant pressure, C is Next, inversely proportional to 1 by root d. See, it is R, C equal to R means rate of diffusion. So students, C is inversely proportional to root d. So where C equal to R, then R rate of diffusion also inversely proportional to square root of density. Rate of diffusion. Rate of diffusion is inversely proportional to square root of density. Square root of density. This is at constant temperature and pressure. At constant temperature and pressure. This is the definition part. So students, Graham's law completed. Next, deduce the kinetic energy. Reduce the kinetic energy from kinetic gas equation. So already known kinetic energy means Ke, already known kinetic gas equation PV equal to 1 by 3 mnc square. This is kinetic gas equation. So it is given above equation multiplied and divided with 2. Multiplied and divided with 2 with 2. So PV equal to 2 by 3 to 1 by 2 mnc square, already known. This is Ke, kinetic energy. PV equal to 2 by 3 into Ke. So already known, where Ke equal to reverse 3 by 2 into PV, already known. PV equal to nRT or RT. So Ke equal to 3 by 2 into RT. This is kinetic energy equation. So 3 by 2 PV ideal gas equation already known, students. PV equal to nRT or RT for 1 mole. This is PV equal to RT. So deduce the kinetic energy from kinetic gas equation. This is kinetic gas equation. This is multiplied and divided with 2. Another equation is obtained. This is kinetic energy. 2 by 3 converted 3 by 2. PV equal to RT. This is a kinetic energy equation. Next one, Dalton's law also taken. So deduce the Dalton's law from kinetic gas equation. So already known, Dalton's law means total pressure is equal to sum of the partial pressure. So this is Dalton's law. So it is taken P1 equal to 1 by 3 M1 N1 C1 square. P2 equal to 1 by 3 M2 N2 C2 square. So it is taken total 2 partial pressure mixture. It is same vessel is taken. Then P equal to 1 by 3 M1 N1 C1 square. Next plus P2 1 by 3 M2 N2 C2 square. This is Dalton's law from kinetic gas equation. So total pressure is equal to sum of the partial pressure. So P1 equal to 1 by 3 M1 N1 C1 square. So this is P2 equal to 1 by 3 M2 N2 C2 square. Then where P equal to P1, or total pressure is equal to sum of the partial pressure. So total partial pressure is taken in same vessel. Then total formula where P equal to P1 plus P2. So next one, state and explain Graham's law of diffusion. Graham's law of diffusion means so at constant temperature and pressure, at constant temperature and pressure, rate of diffusion is inversely proportional to square root of density. Square root of density. So students, rate of diffusion is inversely proportional to square root of density. That is known as it is a rate of diffusion, Graham's law. So Graham's law at constant temperature and pressure, rate of diffusion means R is inversely proportional to square root of density. That is known as Graham's law. Next one, it is also another equation statement 2 also given at constant and temperature and pressure. Another one, at constant temperature and pressure, rate of diffusion is inversely proportional to square root of molecular weight, square root of molecular weight. So students, R is inversely proportional to 1 by root m also. Next one, at constant temperature and pressure, rate of diffusion is inversely proportional to square root of vapor density, square root of Vd. Vd means vapor density. So students, R is inversely proportional to vapor density. So total equation R1 by R2 equal to under root of D2 by D1 and under root of M2 by M1. Next one, under root of Vd2 by Vd1. This is a final equation, Graham's law equation. So rate of diffusion is inversely proportional to square root of density, square root of molecular weight and square root of vapor density. This is state and explain Graham's law of diffusion. So another equation R equal to V by T also, this formula also given. This is volume and time. Next one, RMS velocity. So RMS velocity means, this is symbol C. It is the square root of mean of squares of all the velocity present in the molecules. So students, one formula is given, C equal to under root of 3RT by M. Another equation, C equal to C1 square plus C2 square plus C3 square by N also given. So it is taken C equal to RT also known, RT equal to PV. So it is 3 PV by M. Next one, V by M also known 1 by D. Then C equal to under root of 3P by D. So it is the square root of means of squares of velocities of the all the molecule present in the gas, that is known as present in the gas. This is gas, that is known as RMS velocity. So RMS velocity means the velocity, it is the square root of mean of squares of velocities of the all the molecule present in the gas, that is known as RMS velocity. So C equal to under root of 3RT by M, RT equal to PV, where V by M equal to 1 by D, C equal to under root of 3RT by M, 3PV by M, 3P by D, or C equal to C1 square plus C2 square plus C3 square by N. Another formula also given. Next one, average velocity also present. This is average velocity. Average velocity c equal to c, it is c bar c1 plus c2 plus c3 by n. This is c equal to c1 square plus c2 square plus c3 square by n also given. So next one, so it is the another formula, c bar equal to under root of 8 RT by pi m. C bar equal to under root of 8 PV by phi m, already known. So next one, PV equal to RT. Next one, C bar equal to under root of 8 P by pi d. So next one, V by M, already known students. V by M equal to 1 by d. This is average velocity. There is no square root. So RMS velocity means it is the square root of mean of squares of velocities. Next one, average velocity also observed C1 plus C2 plus C3 by n, where PV equal to RT, V by M equal to 1 by d. Next one, most probable velocity also taken. Most probable velocity. So it is given Cp. Cp equal to under root of 2 RT by m. That is Cp equal to under root of 2 PV by m. V by m equal to 1 by d, already known, 2p by d. So students, this is most probable velocity. Interrelation it is taken, Cp, C bar, C ratio also taken, Cp, C bar, C ratio also present. So Cp, C bar, C. So next one, Cp is to C bar is to C. Next one is it is taken Cp, already known, under root of 2 RT by m. Friends, this is Cp already known, under root of 2 RT by m. Next one, C bar already known, under root of 8 RT by pi m. Next one, under root of 3 RT by m. Already RT by m, RT by m, RT by m. So root 2 is to root 8 by 5 is to root 3, that equal to 1 is to 1.128 is to 1.224. This is final answer. Next one, students, derive ideal gas equation, already known, PV equal to nRT, that equal to ideal gas equation. It is, what is ideal gas? A gas which obeys all gas laws at all temperature and pressure, that is known as ideal gas. It is obtained by three gaseous laws. It is obtained by three gaseous laws. First one, from Boyle's law. Temperature is constant. V is inversely proportional to 1 by P. From Charles' law, pressure is constant. V is directly proportional to T. From Avogadro's law, temperature and pressure is constant. V is directly proportional to N. So this is first equation, this is second, this is third. From 1 to 3, 1 and 2 and 3. So it is taken. So first one, Boyle's law, temperature is constant, volume is inversely proportional to pressure. Charles' law, pressure is constant, volume is directly proportional to temperature. Avogadro's law, equal volume of all gases containing equal number of moles or molecule. So it is given V is inversely proportional to 1 by P. V is directly it is given N. Next one, V is common NT by P, V equal to nRT by P, where PV equal to nRT. This is ideal gas equation. So students, what is ideal gas? A gas which obeys all gas laws at all temperature and pressure. So it is obtained by three gaseous law. According to Boyle's law, at constant temperature, volume is inversely proportional to pressure. Next one, Charles law. At constant pressure, volume is directly proportional to temperature. Next one, according to Avogadro's law, V is directly proportional to N. So final equation, V is NT by P. So V equal to nRT by P. R means proportionality constant. Then PV equal to nRT. So this equation is known as ideal gas equation. So students, ideal gas equation is completed. Next one, so it is given formula R1 by R2 equal to under root of M2 by M1. This problem, this equation is known. This problem is very simple. Already known R1 equal to, so V1 by T1 is taken. So V1 already known. V1 next to 360 centimeter cube, 360 by 15. So it is given, so it is 24. Next one, rate of diffusion R2 equal to volume V2 by T2. V2 volume already known 120 centimeter cube. So next one it is 10. So it is given 12. So R2 value 12, R1 value 24. Next one already given, M1 value is given. M1 equal to methane. Methane molecular weight it equal to 16. So M2 already find out. So this is M2, another gas is M2. So substituted R1 value 24 by this 12 equal to, next one, under root of M2 by 16. Already known M1 value 16 because methane molecular weight 16, 12 plus 4 equal to 16. Then it is taken 24 into 16 by 12 into 12. So that is it is known as M2. This is M2. So M2. Then it is answer 64. 64 molecular weight gas is SO2 gas. So next one students, this is M2 by M1, R1 by R2 equal to under root of M2 by M1, where R1 equal to V1 by T1. V1 means initial volume 360 centimeter cube. T1 already given, it is 15 minutes. Next one, R2 value also given 120 centimeter cube volume. It is diffused, time also given 10. So it is substituted all values. M1 it is known, M1 equal to methane 12 plus 4 equal to 16. Methane molecular weight equal to 16. M2 find out, then M2 equal to, this is 64 molecular weight compound SO2. SO2 means sulfur dioxide. This is very simple problem. So students, 4 marks all are very important. So it is main important answer, postulates of kinetic molecular theory, very important answer, and ideal gas also most important. So students, next explanation part, VSAQ, states of matter. So next one, so what are isotherm? Isotherm already known, it is indicated to Boyle's law. Isotherm is temperature is constant. So at constant temperature, a graph plotted between pressure and volume. Pressure and volume is known as isotherm. So students, isotherm indicates Boyle's law. Isobar indicates Charles law. Isochore indicates Charles Gay-Lussac law. So it is given Isotherm means temperature is constant. At constant temperature, a graph plotted between pressure and volume, that is known as isotherm. So isotherm indicates Boyle's law. Isotherm indicates Boyle's law, students. So a graph plotted between pressure and volume at constant temperature is known as isotherm. It indicates Boyle's law. Next one, STP condition means standard temperature and pressure. Standard temperature and pressure. Temperature is standard condition 0 degrees Celsius temperature. Pressure is 1 bar. So that is known as standard temperature and pressure. So students, STP means standard temperature and pressure. Temperature is 0 degrees Celsius or 273 Kelvin. Pressure is 1 bar. That is known as a standard temperature and pressure condition, STP condition. So why R is called universal gas constant? So because R is same for all gases. R value, R means universal gas constant is same for all gases. So why R is called universal gas constant? Universal gas constant means it is R value is same for all gases. So R is known as universal gas constant. Next one, which of the gases N2O2 CH4? CH4 is faster because low molecular weight. Low molecular weight. So students observe. So if molecular weight is less, rate of diffusion is faster. If molecular weight is higher, rate of diffusion is slower. So rate of diffusion is inversely proportional to square root of molecular weight. So it is given. So N2 molecular weight 28, O2 molecular weight 32, CH4 molecular weight 16. So least molecular weight, that is CH4, this is rate of diffusion is faster. So methane rate of diffusion is faster. Rate of diffusion is faster because low molecular weight. Low molecular weight. MW means molecular weight. So next one, students. How many times methane diffuses faster among sulfur dioxide? R1 by R2 equal to under root of M2 by M1. So it is given M2 equal to SO2, M1 equal to methane. This molecular weight 64, this molecular weight 16, molecular weight methane. So substituted R1 by R2 equal to under root of 64 by 16, that equal to, it is R1 by R2 equal to, so it is root 4 value already known, root 4 value 2. So methane, it is given diffuses 2 times faster than sulfur dioxide. So R1 by R2 equal to under root of M2 by M1. M2 means sulfur dioxide, M1 means methane, 16 4 ja root 4 value 2. So methane, this is 2 times diffuses faster among the sulfur dioxide. Next one, give the reaction between partial pressure. So partial pressure PA equal to mole fraction X into total pressure P total. So P partial pressure, that equal to P partial. Partial pressure equal to, this is mole fraction into total pressure. This is mole fraction. So partial pressure equal to, partial pressure equal to mole fraction into total pressure. So this is a relation between partial pressure and gas its mole fraction. Next one, What is Boltzmann constant? The gas constant per molecule is known as Boltzmann constant. The gas constant per molecule is known as Boltzmann constant. Already formula K equal to R by N. So K value X 1.38 into 10 to the power of minus 16 X Kelvin inverse molecule inverse. Joules is taken 10 to the power of minus 23 joules Kelvin inverse and molecule inverse also given. Next one, it is what is Boltzmann constant? Boltzmann constant means the gas constant per molecule, that is known as Boltzmann constant, symbol K equal to R by N. So K values are so given. X 1.38 equal to 10 to the power of minus 16 X joules 10 to the power of minus 23 joules. Kelvin inverse and molecule inverse also. Next, what is Boyle's temperature? The temperature it is given, the temperature at which real gas converted into ideal gas behavior, real gas converted into ideal gas behavior is known as Boyle's temperature. So next one, so it is given at high altitude atmospheric pressure is low. At high altitude atmospheric pressure is low. So pressure cookers is used for cooking food on hills because main region this is atmospheric pressure is low. Next one, Ke equal to 3 by 2 nRT already known. So it is given. So this equation calories also taken, R value 2, substituted 3 by 2. Already moles is given 5 moles, R value calorie 2, 27 plus 273, 300 kelvins. So it is taken. So it is 3 5 ja 15 for 4500 calories. This is answer. So students, kinetic energy formula Ke equal to 3 by 2 nRT. N value already given 5, R value calories low 2. Next one 27 plus 273 300 Kelvin. So it is given, this is 4500 calories. It is R value, 2 is calories taken, answer also calories. Next one, state Boyle's law. At constant temperature, volume is inversely proportional to pressure. So that is known as Boyle's law. Volume is inversely proportional to pressure. That is known as Boyle's law. Next one, isochore volume. At constant volume, a graph plotted between pressure and temperature, So isochore means volume is constant, pressure, temperature, volume. So volume is constant, remaining graph plotted between pressure and volume, temperature, that is known as isochore. So it is given already known, Ke equal to 3 by 2 nRT. So next one, N equal to taken 4 moles. Next kinetic energy 4 moles of methane 4 by 16, that equal to 0.25 already known. Next one, R value, it is taken 2 also taken, R value, calories also 2. Next one, R, next it is SI units also taken 8.314 calories, joules 8.314 joules. Next one, temperature equal to 273 minus 73 equal to 200 kelvins. So next substituted Ke equal to 3 by 2 into 0.25 into next one 8.314 into 200, it is generally 623.6 joules. Next one, it is given Ke1 by Ke2 equal to, it is given N2 by N1, it is formula N1 by N2. So 3 by 2 is 4 by 32. Students, it is 4 by 32. Next, it is equal to 12 is to 1. So students, 3 by 2 is 4 by 32. That formula Ke1 by Ke2 equal to N1 by N2. Next one, so this is all 2 marks. So states of matter 4 marks and 2 marks is completed. So thank you students.